Hello, everyone. In this lecture, we are going to test on a proportion. Okay, if you have a population, you have a proportion product, they may be failed and or they are defective. So we want to test on this proportion. So many engineering decision problems include hypothesis testing about a proportion P. So this P equals to P0 or P does not equals to P0. This is two-sided test. If the null hypothesis is true, okay, then we have X is approximately normally distributed with NP0 and NP1 minus P0. So null hypothesis is P equals to P0. Alternative hypothesis, you have three of them. So P does not equals to P0, P greater than P0, or P less than P0. And we have different kind of rejection criteria based on the test statistics, because X follows this normal distribution. So that's why we have this test statistic. This will be converted to the Z test, that is the first test we discussed. Okay, now let's look at this exercise together. So a semiconductor manufacturer produce controllers used in automobile engine applications. The customer requires that the process fallout or fraction defective at a critical manufacturing step not exceed 0.05. And that the manufacturer demonstrated process capability at this level of quality using alpha equals to 0.05. The semiconductor manufacturer takes a random sample of 200 devices and finds that 4 of them are defective. Can the manufacturer demonstrate process capability for the customer? And you can think about this is a semiconductor manufacturer, okay? They produce controllers. However, you can think about different kind of manufacturing, additive manufacturing, or you can produce the part, right? Now, what is a fraction defective if you produce many of them? So can you demonstrate the process capability or not? So those are this kind of test. So you can only demonstrate the capability if it is not exceed 0.05. That means not exceed 5% of defective, you will be able to demonstrate the process capability. Now to test on the proportion, we know the rejection criteria right here. We know the test statistic. Now we will be able to do the test. Step 1, formulate hypothesis. That is H not P equals to 0.05, and alternative hypothesis P less than 0.05. Okay, whether we can demonstrate the capability or not. So if the null hypothesis is rejected, then we will be able to demonstrate our capability, right? So the significant level, alpha equals to 0.05. This is our significant level. Step 2, compute the test statistic. That is Z0 equals to X minus NP0 divided by square root of NP0 1 minus P0. So this will equals to, you see here, 5, right? 4 of them. And then you have 200 times 0.05 divided by 200 times 0.05 times 0.95, then square root. So this will equals to minus 1.95. Step 3, we are going to reject H0 if Z0 is less than minus Z0.05 minus 1.645. You see here, we don't split alpha because you have 5%, you don't have alpha over 2. Why? Because this is one-sided test. If we look at the, okay. So in the hypothesis formula that I posted online, you will be able to see all the formulas for this one. Oh, it's right here. So this is less than, so this should be minus Z alpha. So that's why this is minus Z alpha. We're going to reject step 4. You see, minus 1.95 is less than minus 1.645. Therefore, we reject H naught, okay? And conclude that the process fraction defective is less than we can conclude. We can conclude that the process fraction defective P is less than 0.05. The p-value equals to 0.0256. If you want to use p-value approach, this is also less than 0.05. That means you reject the null hypothesis. So we conclude that this process is very capable. The process is capable. Okay, so this is how do we do the quality engineering based on the data we have and also based on the hypothesis testing. We're not going to make a decision. We're going to assume there are randomness and there are random distributions. And then we're going to test the mean, test the variance, and also test the difference between two means, two population means, and test on the difference between two population variances. Now we are testing on the proportions. And in the next video, we're going to talk about test on the difference of two proportions. This is the end of this exercise.